26th. Okay, so we're told that Q varies jointly with V and the square of W. Jointly with V and the square of W. And then the problem is giving us if W is 20 and when V is 12, then Q is 80. So all this information is given to us because that's all we need to solve for K, find K. So the model is not fully determined unless we have K. So 80 equals K times 12 times 20 squared. Any questions so far? So therefore, I have to divide both sides by this number. I don't care to multiply it right now. I would like to do this and then say 20 squared is 400. So then I see that I can cross out a 0. I can cross out an 8. So therefore, K equals 1 over 60. I have to go back and put it in. So the model now fully, clearly determined, everything is done, is this. And I can answer the question. Find Q when W is 10 and when V is 15. So Q equals 1 over 60 times 15 times 100. Any questions on this? So I will simplify. A 0, or I can say 15 and 60 is 4, and 100 divided by 4 is what am I doing? So divided by 3, I started like that. So divided by 3, so it's 2, and this is 5, so it's 50 divided by 2. Is that correct? Is it 25? Perfect. Okay. Anything else? Other questions? Is there anything else? Say it again. Yes. Your error in the extra credit when you multiplied, I think. Everything was fine. Something here when you multiplied by, this was supposed to be multiplied by 12 because it's 4 times 3, and this was supposed to be multiplied by 3. Yeah, everything else was, you're on the right track. Okay, anything else? The handout that I gave you today, I'm hoping we can start, but it doesn't necessarily mean that. This is chapter 10. So we have to, this is a summary of the entire chapter 10. Chapter 10 is a very important chapter. It's not as interesting as I really would like to present to you. It's not. And this handout will help us. I created this over the summer because I realized that it's such a drag, this chapter. But going through this handout first and then looking at the problems in the book, I think it will help us. So, but this is only after we finished it, 9.2, 3, and 4. Okay, anything else before we start chapter 9? I mean, we go back to chapter 9. We started it a long time ago. So 9.2 through 9.4. For some reason, from my experience, this chapter creates a little bit of a problem. Only if students don't follow me in trying to understand what we're trying to do, but just memorizing stuff. I don't recommend that. Because at some point in time, you will forget if you memorize it. But if you understand it, then it will be definitely much better. It will stick. Okay. Any questions before we start this? Is there anything else? So for those of you who just came in, please make sure you add up your points on the test. Make sure I didn't make a mistake. And if I did, please don't get frustrated at the end of the class. I'll correct it. But just don't write anything on the test before you show it to me if you have claims. Okay, in chapter 9, go back to chapter 9, which chapter 9 was about inequalities. So now we're going to look at 9.2, which is, first of all, absolute value equations. You can say, okay, you just said that the chapter is about inequalities and you start with an equation. I have to start with an equation. Absolute value equations. That's our first target here in 9.2. Okay, how many different types of equations we know so far? Well, we basically know linear, right? Where we move terms to one on the terms with variable on one side and the terms with no variable to the other. And then we divide or whatever we need to do. And the other one that we know, and we can only solve it by factoring, that we know from the previous course, is quadratic, right? We may be able to solve higher degree polynomial equations only if they're factorable, and we don't know really much about higher degree than 2. So 1, degree 1, and degree 2. Now, these equations are not degree 1 and are not degree 2. Totally different. So how will the simplest possible absolute value equation look like? It's the absolute value of x, and just give me a positive number. Perfect. Okay. Now, what is important here is when you look at this, what it tells you. Everyone can eventually solve this equation, but what it tells you is more important. So when I look at this equation, here's what goes through my mind. What is the absolute value of a number, first of all, before I say what I'm thinking about? So when I say the absolute value of 3, well, I know the answer is 3, but what does it mean? Exactly, the distance from 0. That's why it's 3 units. That's what it means. What about the absolute value of -3? What will that be? It depends on how far away -3 is from 0. How many units is -3 away from 0? 3. That's why the answer is 3. Good. So coming back to our task at hand, which is this. Assuming you're giving me this equation to solve, this is what goes to my mind. I'm asked to find numbers x whose distance from 0 is 7 units. Numbers named x whose distance from 0, that's what it means, distance from 0, is 7. So now, yes?
Couldn't that be 2?
Couldn't be what?
It could be 2.
Correct. That's why it's not linear. Yes. So, yes, what can x be?
-7 or positive.
Exactly. X can be 7 and x can be -7. Now, pay attention to the fact that we cannot really solve this. I have to convert it into what it equals. So solving this is like solving this. It happens that they're already solved. But what if I have a different situation, slightly more difficult? Like, let's say the absolute value of 2x minus 1 equals 2. What happens now? The concept stays. The thinking process is the same. Here's how I think. This time I want to determine these numbers, whatever they are, whose distance from 0 is exactly 2 units. So what can this number be in here? Exactly, and this is what I have to write. So I have two options for 2x minus 1, to be 2, or 2x minus 1 to be -2. As you notice, this is not done. Here it was, because it was one of the simplest possible absolute value equations, but here is not done. I have to move 1 and divide by 2 in both cases. So when I move 1 and divide by 2, I get x equals 3/2. So when I move 1 and divide by 2, I get x equals -1/2. Any questions? Of course, I can have different variations, and I can make it as complicated as possible. For example, -2, the absolute value of x plus 1 divided by 3, minus 4 equals 8. Well, this needs cleaning up, right? So what will be the first step towards cleaning it up? And of course, I have to have plain, clean absolute value on one side. Otherwise, I can't conclude. Have to have plain, clean absolute value on one side and a positive number on the other. Because this is always a positive quantity, unless I have a minus in front. That's a different story. But other than that, this will always be a positive number. It could be 0, but greater than or equal to 0. And this has to be a positive number, or 0. Both sides 0 or both sides positive. Okay, and how do I clean this up? I cannot add this to this. This is multiplied. If there is no symbol, that's why it can get confusing. If there is no symbol, it means it's a multiplication. I cannot ever, and I have to write that as a note. Let's write as a note. The absolute value bars, or symbol if you want, whatever you want to write, is not a grouping symbol. In a grouping symbol, like parentheses, I can distribute. Here I cannot. So the absolute value symbol or the absolute value bars are not grouping symbols. -2 cannot be distributed. Nothing can be distributed inside. So do not treat the absolute value bars like parentheses or brackets. You cannot do that. So coming back, the question is, what do I do? How do I clean this up? And in other words, solve it for the absolute value. Becky, go ahead. Yes. Note, the absolute value bars or symbol, depending on how you want to call it, is not, so, or are not. If you use bars, then I have to use are not. So the absolute value symbol is not a grouping symbol, or the absolute value bars are not a grouping symbol. They don't form a grouping symbol. Okay, so coming back, how do I clean this up?
Add 4.
Yes, I can only add 4. So -2, the absolute value of x plus 1 divided by 3 equals 12. I still haven't cleaned it up completely. I have one more step. What will that be? Good. So when I divide both sides by -2, I get the left-hand side to be the absolute value of x plus 1 divided by 3, and the other side will be -6. I look at this equation and I say, no. What does that mean? It's like me telling you, or someone telling you, that a positive number, which is this, equals a negative number, which is this. What do we conclude here?
No solution.
No solutions. I would like to start a log. Log of types of solutions for absolute value equations. And there are 4 possibilities here. Log of types of solutions for absolute value equations. Okay. The very first 2 equations that we looked at, how many solutions did we obtain? 2 solutions here, 2 solutions here. So that's one option. 2 possible solutions. The third one that we just looked at, how many solutions did the third one have? No solutions, indeed. Very good. So let's look at the other two, 3 and 4. Let me give you an example. The absolute value of x plus 1 divided by 3 is 0. So the same thing, I cover it in my mind. I think, okay, I'm asked to find numbers whose distance from 0 is 0. What can this be? Yes. So from here, I'll say only x plus 1 divided by 3 can be 0. There is nothing else. I don't have 2 options in this case. How do I solve such an equation? What do I have to do first? I cannot, before, I will subtract 1, but I cannot subtract 1 as is. I have to multiply by 3 first. So I have x plus 1 equals 0, and then I subtract 1. So how many solutions did this equation have? 1. So that's the third option. 1 solution. Let's draw a conclusion so far about what we've seen till this moment. Now we know that if I have an expression, any expression in absolute value equals, let's say, a positive number, p, positive number, then I know that there are 2 possibilities. What are the possibilities again? The expression to be what can I have in here? P, right? Because only the absolute value of P will be P. Very good. And what is the other option for the expression to be?
Negative P.
Correct. So this is the bottom line so far. So the inside, whatever it is, not X, the whole thing can be P or negative P, as we saw here. Not X, right? This was a special case, a very simple case, in which I only had an expression that contained only X. But this one is not X, right? 2x minus 1 is that or this. And then I have to continue solving it. Perfect. So keep this in mind. Again, this is the bottom line. Now, what if I have 2 absolute value expressions? Let me give you an example. Let's say the absolute value of x minus 1 equals the absolute value of 4x minus 2. Will this really differ from that? How many options would there be? Would there be in this case, in this situation? Well, one possibility will be that x minus 1 equals 4x minus 2, which is basically this situation. The second possibility will be that x minus 1 equals the opposite of 4x minus 2. What are the other 2? What do you think? Well, let's see if I start from here. Let's see, I have it reversed, right? Then I will have what? 4x minus 2 equals x minus 1, or 4x minus 2 equals negative x minus 1. But let's look carefully. Do I really have 4 different situations? So stay with me. Would you agree that this is absolutely the same with this? Would you agree that this is the same with this? Yes?
Yes.
So there is no point in writing it again. Would you agree that this is absolutely the same with this? If I multiply both sides by negative 1, this will become will have positive in front and this will have negative in front. So let's multiply both sides here by -1. This is x minus 1. And this is negative 4x minus 2. So if I multiply this both sides by -1, do I obtain the previous one? Look. Yes? Is that clear, Becky? See? Yes. The minus was, there was a minus in front. It became positive. And there was no minus in front and became negative. But this piece is identical with this. And this piece is identical with this. So bottom line is we only have two options. The other two are a repeat of the previous two. So let's go ahead and solve them. So the first possibility is x minus 1 equals 4x minus 2. How do I address this? What type of equation is it? And how do I start? What do I do? Can anyone comment on what type of equation is it?
Linear.
Of course. So then I have to move x, do whatever you want. You don't have to wait for me. I'm going to subtract 4x and I get negative 3x. And I'm going to add 1 and I get negative 1. So I have x equals negative 1/3. Don't wait for me. You calculate it the way you like. You solve it the way you like. And here's the second option. Second option is x minus 1 equals negative 4x plus 2. Still linear. You do whatever you want. Again, I'm going to bring 4x and I'm going to bring 1. So then I have 5x equals 3, x equals 3/5. And here are my two solutions. Still nothing to add to our log, because this is two possible solutions. I encountered this before. So I'm waiting anxiously for the fourth possibility in a minute. But I needed this first. Okay, so now let me come up with an example for the fourth possibility before we look in the book. And let's say this is 1 minus 2y equals the absolute value of 2y minus 1. Can anyone dictate? Although we would be tempted to write 4 different situations, we already know there are only 2 distinct. Can anyone give us an idea of how to proceed? What do I have to write in this case? Option number 1 and option number 2. Option number 1.
1 minus 2y equals 2y minus 1.
Perfect. And option number 2. Very good. Excellent. Perfect. So let's start by solving the first one. It doesn't matter. The order is not important. We established 2 different situations. You start with the one you like. Let's say we start with 1. 1 minus 2y equals 2y minus 1. I want to bring y to one side. I prefer the left. You can solve it the way you like. Negative 4y. And I bring 1 to the other side and I get negative 2. And the answer is y equals negative 2 over negative 4, or 1/2. Any questions so far? Okay, so now let's solve the second one. 1 minus 2y equals negative 2y plus 1. Any suggestions on this one? I'm getting the book. can choose examples from there too. So what do you think?
Ends up being 0 equals 0.
Right. What does this mean? How is this called or this called? How are they called? Infinite solutions, but they are called, very good, identities. What does that mean? The left-hand side equals the right-hand side no matter what. It does not depend on x, it does not depend on y, it does not depend on anything. 0 will always be 0. So we will have to say infinitely many solutions. Of course, 1/2 is included in the infinitely many solutions. I don't have to write it again. It's already in here. So coming back to our log, what will be the fourth possibility when solving absolute value equations? Very good. Infinitely many solutions. So this is what you should always have in mind whenever you are given an absolute value equation. A light should come on and say, okay, I have 4 possibilities. 1 solution, 2 solutions, no solutions, infinitely many solutions. Okay? So on page 653, anything you like to work on from 1 through 68. One through 68, page 563. Do I choose? Okay, you trust me then. Let's start with 49. And let's say 5x plus 1 equals the absolute value of 4x minus 7. Let's work on this problem for 1 minute. Raise your hand if you have any questions or if you need help. Yes, Becky? Yes, from before? Yes. Let me know if you need help, please. Do we have an answer? I'm just putting in my attendance. Do we have an answer? Daniel, Mike, Jackie, Riley. Okay. Okay, so obviously there are 2 possibilities. Even if we're tempted to write 4, we know there are only 2. First possibility is 5x plus 1 equals 4x minus 7. Now I have to say that this method that I'm showing you is the method in the book, but if we have 3 absolute values, this method doesn't work. You're not going to see 3 absolute values in this class. You're going to see only 2. But with 3, this method is not working. Okay, so I'm moving 4x, so I have x, and I'm moving 1, so I have -8. That's my first option. Is that correct? Good. Second possibility is 5x plus 1 equals negative 4x and plus 7. I'm adding 4x, so I get 9x. I'm subtracting 1, so I get 6. So x equals 2/3 as the second option. Do we agree?
Yes.
Okay. Should we choose other problems or move on? It's up to you. Did we get the idea with 1 or 2 absolute values? Would you like to practice some more, or we continue to the next section? One more. With 2 or 1? With 2? Okay, very good. So let's say 54. On the same page, 563. And it reads 4n. I'm going to change it to x because when I write n, students don't really appreciate my n. I'm kidding. It looks like an m, so to avoid confusion, I change it to x. So let's work on this. 1 minute. Ready? Okay. Thank you. Do we need more time? Okay. So I subtract 4x from both sides, and I get that 5 equals 3. Of course, no solutions. This equation is called contradiction. No solutions. Must be a contradiction. I'm adding 4x, so I have 8x, and I'm subtracting 5, so I get negative 8, so x equals negative 1, and this is the only solution. An equation that has a solution or more is called conditional. It is true only for negative 1, x being negative 1. It's not true for anything else. That's why we call it conditional. So we have basically 3 types: contradiction, conditional, and identity. Identity has infinitely many solutions. Contradiction has none. When an equation has solutions, it's called conditional. It's true only for this value. That's the condition. X must be negative 1 for this to be true. For anything else, it's false. Very good. So I think we're ready now to move on to, oh, I wanted to ask you a question. Let's suppose, and that's question 84 on page 564. Let's read the question. Write an absolute value equation representing all numbers x whose distance from 7 is 2 units. Write an absolute value equation that represents values of x whose distance from 7 is 2 units. How will I express that? Distance from 7 is 2 units.
absolute value of 2 equals 7.
No, equals 2. Whatever is 2. So what do I have in the absolute value?
Minus 7.
That's it. The distance from x and 7 is x minus 7. Or you can say this is the distance, this is the distance between x minus 7 and 0. The distance between x minus 7 and 0 is the same with the distance between x and 7. Yes, so this is true. This is it. Okay, 9.3. Finally, absolute value inequalities. Absolute value inequalities. And we have 2 types. Again, I'm going to start with the simplest possible ones. This one. Of course, I can have the symbol just less than. It can be just less than or equal to. And here's the second option, the second type. Of course, the symbol can be also just greater than. Again, what is important here is to understand what we're asked to do. Like before, and I promised to write it and I didn't. So again, no, I did. The absolute value, the distance. Okay, so anyway, I'm going to write it here one more time because I want to emphasize what happens here. So this equation is really telling us what? Find x such that the distance between x and 0 is 7 units. I promised to write it and I didn't. This is what it means. However, what do you think this one means? Very similar. The concept is very similar, but something has to be changed because it's not equal symbol, but inequality symbol. So this will mean what? I'm going to write it. Find x or x values such that the distance between x and 0
Less than or equal to 7.
exactly. That's what this means. So I'm asked to find these numbers whose distance from 0 is not 7, but 7 or less. So let's look at the real line for a moment. So here's the real line or the number line from negative infinity to infinity. Somewhere in the middle I have 0. Where will I find the solutions of this on the real line? What are the solutions of this equation?
-7.
Right. So right here at -7 and here at 7. So these two x values represent solutions to this. Now, one more time, what is this? What does this say to us? It says find x values whose distance from 0, x, the distance from 0 and x, is 7 units or less. As you see here, I have 3 possibilities. I have this interval, I have this interval, and I have this interval. Where will I find numbers whose distance from 0 is 7 units or less?
Between -7.
Exactly. So right here. This will be the solution to the absolute value of x less than or equal to 7. That's where I will find the numbers whose distance from 0 is less than 7. In between, in other words, in between -7 and 7. So let me write this for you again here. So I shouldn't say again, let's write it. This means find x values, of course, such that the distance between x and 0 is 7 units or less. Now the question is, how do I write the solution? Or how do I convert this? See, when we solve this equation, we convert it into two other equations, x equals 7, x equals negative 7. Same thing here. When I try to solve this inequality, I can't directly. I have to change it into exactly what you just told me. How will I change that? We've seen this before, even on this test. How will I change this to reflect this interval?
Interval notation.
Before that, yes, the interval notation would be negative 7, 7. But how do I write this to reflect that? That's it. And yes, of course, the interval notation is negative 7, 7. Perfect. So now if I go back to the general case and I ask you, okay, let's see what we write for any expression, anything you want, less than or equal to a positive number. How do I convert this into something I can solve? Because I studied 9.1. I know how to solve this. So how will this convert? It's exactly what you gave me here. It's the same. Negative p less than or equal to. Yes, it's the expression now, whatever that is, not necessarily x, it can be anything. And then less than or equal to, that's it. So this is the general case. And now let's look at a couple of examples. So let's say I have the absolute value of x plus 1 divided by 3 less than or equal to 2. Again, I'm asked what? I'm asked to find these numbers whose distance from 0 is 2 units or less. Where will I find 2 units or less? Right. How do I express that? Because I have to change it. Don't do this. I'm just making a point. I don't know how to solve this. If I am not able to change it into something, I can look at it for the rest of the evening and I will not be able to solve it. So this has to be converted into what? And you have right here the general case.
Negative 2 less than or equal to x plus 1 over 3.
That's it. This is the conversion. We don't know this, but we can solve that. We've done this many times before. Once I understand how to convert it, the rest should be straightforward. So now I'm asking you, how do I solve this?
Multiply by 3.
Multiply everything by 3. The left-hand side is negative 6. The middle side, I've seen this mistake in your tests, so allow me to take a short break and show this. Some of you did this, multiplied the fraction in the middle. You eliminated the denominator, but you still distributed 3x plus 1, plus 3, 3x plus 3. No, right? So we do this because we want to eliminate the denominator. So the middle part is just x plus 1, not 3x plus 3 that I saw in your. So please go back and look at that. And then less than or equal to 6. You have to multiply all 3 sides. I did see that mistake as well. You multiply the, 1 or 2 sides, but not the third one. We cannot do that because we change the problem if we do that. So finally, what will be the next step?
Okay.
Yes. So I have negative 7 less than or equal to x less than or equal to 5. In interval notation, negative 7, 5, x in. So let's try to analyze what this means. For this number, whatever this is, for this number to have a distance from 2, or distance from 0 less than or equal to 2 units, x itself has to be picked between -7 and 5. If I pick x between -7 and 5, this number will have the distance from 0, guaranteed, less than 2 units. This is widely used in measurements for a tolerance. So when they say, for example, the length of my marker can be plus or minus 0.5 inch, that is obtained with something like this, with an absolute value inequality. Okay, very important. Okay, so let's look at other examples and then discuss the third. It's the second one, but the third situation with absolute value. Okay, let's practice this one on page 568 and page 569. (568, 569). I'm going to pick 41. If you want to pick, please feel free. The absolute to do so. Okay. So let's think about this for a moment. I'll stop my video. I still have a few more minutes. Can anyone get us started? Can anyone convert this into something we know how to solve? Because right now we don't. Yes. Yes. Very clear. This number, to have a distance from 0 of 11 or less, this number must be found between -11 and 11. And this we know how to solve. I will have to do what first? Right? So I have -4 less than or equal to 2x less than or equal to 18. I added 7 to all three sides. And now, very good, I divide everything by 2 and I get -2 less than or equal to x less than or equal to 9. It turns out, one more time, let's interpret this. The absolute value of 2x minus 7 is less than or equal to 11 only if I pick x between -2 and 9. So if I pick x anywhere between -2 and 9 and plug it in here, this number will be less than or equal to 11. If I pick to the right of 9 or to the left of -2 and plug it in, this number will not be less than or equal to 11. That's what it means. Any questions? Okay, the last one. The third type. Can anyone translate this in words for us? We know how to translate this in words. I'm trying to find numbers x whose distance from 0 is less than or equal to 7. Less than or equal to 7. Numbers, yes, Becky?
Find x such that the distance between x and 0 is 7 units or greater.
Yes, exactly. So this was already occupied. I cannot put it in any other inequality. So now I want to determine numbers whose distance from 0 is 7 or more. I'm done with 7 or less. Now I want to find 7 or more. So I'm coming back to my graph. This is occupied. Done. I cannot include this in anything else. So where will I find numbers whose distance from 0 is 7 or more? This number has a distance from 0 more than 7. This number has a distance from 0 more than 7. All these numbers here have the distance less than 7 from 0. So obviously it's going to be here as well as here. And something like this we've seen in section 9.1. Which keyword will that work with? Very good. Union or. Exactly. Perfect. So then, coming back to my simple example, actually it was yours. How do I convert this? And it cannot be in a chain. Remember, I can put the chain here between -7 and 7. That's a chain. It's an end. And I can solve them together. But this, I cannot. They have to be completely separate. Greater than or equal to 7 or what? Or equal to? Exactly. So x greater than or equal to 7 or x less than or equal to -7. We're not switching the inequality. We're looking for solutions, right? Greater than or equal to 7 or less than or equal to -7. Nothing in between can be included. This is already done. It's taken by a different situation. So now, how do I write the solution? Right, the interval notation is right here. It's in orange. So what is it? For this particular simple example, x in the interval with a bracket, union, that's it. Once you understand that, you will not have to memorize anything. If the inequality says less than, the absolute value is on one side and the absolute value is less than or equal to a number, then you are looking in between. If the absolute value is on one side and it's greater than or equal to a positive number, then you are looking at the outside. So let's practice that. Let's say page, problem 60. And that is 7 plus x divided by 2 in absolute value greater than or equal to 4. And before that, I should write the general case. I know you know it already, but let's write a general case. An expression in absolute value greater than or equal to a positive number. How do I convert this one? Remember, on the previous situation, we had the in-between situation, or answer, in between. This one is what? Two completely separate inequalities. What are they?
The expression is greater than or equal to p, or the expression is less than or equal to -p.
Exactly. Exactly. Thank you, Riley. So let's do this. Work on it for 1 second.